TS3. Question 6. It says in a Daytona 500 auto race, a Ford Thunderbird and a Mercedes Benz are moving side by side down a straight away at 71.5 meters per second. The driver of the Thunderbird realizes that she must make a pit stop, and she smoothly slows to a stopover at a distance of 20 meters. Since she spends 5 seconds in the pit and then accelerates out, reaching her previous speed of 7.1 meters per second after a distance of 350 meters. At this point, how far has the Thunderbird fallen behind the Mercedes Benz? So now in this question, you have to have a picture of exactly what's happening. So now here we have the Thunderbird that starts at a certain point. It goes to a distance. It stops over a distance of 250. So here it was at 7.15, then it goes down to 0, and then he spends 5 seconds here. And then he starts again and then goes to her previous speed. Her previous speed of, here she was at 0, then she goes to her previous speed of 7.71.5. So now this Ford this Mercedes Benz guy, this guy has been moving for 71.5 meters per second non-stop, and then we're being told how far is this guy from this one. So now the only thing that we have to find out is we don't know this guy's time, but then this guy here he moved from 0, he moved to 7.1 meters per second at a distance of 350. So you know this guy's distance is just this one plus this one, which is equal to 600 meters. So as the total distance for the Thunderbird, but then we don't know this guy's distance. This is his speed. So when you find the time that it took, we're going to know this guy's distance, and then we'll subtract this guy's distance from this guy's distance. Now remember, these guys are spending the same amount of time. Even as this guy is resting, this guy is moving, but then the time remains the same. So we're going to try to find, we know this time, so we're going to try to find T1, this is T2 and T3. So we're going to try to find T1 and T3. Then when we add them, we're going to have the time, which is the same time for both of these guys. Then we find this guy's distance that he has moved in that time, because we know he was moving at a constant velocity. So now T1 will be given by T1 will be given by, okay, there are a lot of equations that we can use, but for now we've only been given the velocity and the distance, but we have got both final and initial, since this one's going at 0, this one's coming from 0. So now we can start with finding acceleration first, then you find the time, because when you look at our equations, v is equal to at plus u, v squared is equal to v naught squared plus 2as so there's this one, then the last one is x is equal to x naught plus v naught t plus 1/2 t squared. So now the one that we can use to find our time, we can, this is acceleration, not gravity. We can use this one, we can use this one as well, but then we don't have the acceleration. Even this one we don't have the acceleration, but then at least these two have got the time, so you can use one of them to find, you can use this one to find the acceleration, since I've got the distance and the velocities. Then use the acceleration here to find the velocity, to find the time there. So starting with, let's say this is 1, this is 2, this is 3, starting with equation 2, starting with equation 2, we're going to say our final velocity is 0, it's going to a stop. Our initial velocity is velocity initial is 71.5. This one is squared plus 2. Our acceleration, well, it's just a. Our distance is 250. So then we can make a the subject of the formula by taking this on that side. We're going to get our calculator, and 71.5 to the power 2, that's this figure. So taking this side, we're going to have negative 5,104.25 being equal to this one, that's 500, 250 times 2, over 500 over 500. We're going to have a being equal to this one divided by 500, 10.22, but then in this case it's going to be negative because of the negative that's there. Then to find the time, we're going to say when you make t subject of formula, there we're going to have t. I'll put this as t1 is equal to v minus u over. So then t1 is going to be equal to the final velocity is 0, the initial velocity t is equal to 0 minus negative 7.15 over the acceleration, which is negative acceleration which is negative 10 point what's this now, 10.2 to the one that's here, and then the velocity will be the initial velocity is positive because it's going in the positive direction. So then negative times negative, that's positive. So t1 is going to be equal to when you punch in the calculator, you're going to have 6.996 seconds. So that's for t1. The t1 there is going to be 6.99 seconds, 6.996 seconds. So then what's remaining is the time there. So we can go on and calculate t3. So t3 is going to be equal to for this one we're going to use the formula for average velocity because we don't know any other variables like acceleration and stuff like that. So I'm going to say the time is equal to the distance over the time is equal to the distance over the speed, because now speed is equal to distance over time, so time is equal to speed over distance. So t3 is going to be equal to when you take our average distance, we're going to have our average velocity, our average speed, which is v plus v1 plus v2 over 2. So then our t now is going to be t2 is going to be equal to our distance for the third one is that's 350 over our velocity. It's coming from our velocity, that's final plus initial anything. It's coming down to 7.15 plus 0 over 2. So then our t3, when you punch in the calculator, it will be 9.79 seconds. So then our final time, our t3 is 9.79, is it? Yeah, seconds. So then to sum them up, we're going to have time total is going to be equal to 9.79 plus 5 plus 6.996. So now total time is going to be equal to, when you calculate, it's going to give you 21.786 seconds. And then now to find our distance, to find our the question was telling us to find the question was telling us to find the distance. the separation distance. So we have our first one, which is 600 for the Thunderbird. Then for the Mercedes, we have the total time that it took is 21.786. So now we can say we can find the distance. So the distance of by the Mercedes Benz is going to be equal to the velocity times the time. The time is the total time, the velocity is the velocity of the Mercedes Benz, which is 71.5. So the distance by the Mercedes Benz is going to be equal to 71.5. Then the time will be 21.786. When you multiply, the distance is going to give you 1557.7. So when you subtract, xb will give you 1557.7 minus 600. So xb is going to be equal to 957.7 meters. So that's the distance of separation between the two. So you can try to confirm this. You can try to find the times and the distances, and you try to subtract or try to plug in the values that we found initially back to this one. You're going to find still the same thing. So that's all for tutorial sheet 3. We are going to go to tutorial sheet 4 in the next videos to come.